Oh, guys, I had a great lecture that I just recorded, and my ScreenFlow software just sort of intermittently decides that it's not going to record my iPad. So I recorded a whole lecture without the whiteboard. So I think I had to restart my computer, and I think that it's capturing the iPad again. So I'm going to give it a second shot. Okay, conditionals. So we're going to go through a couple of examples that will increasingly build on more complex conditional examples. We're going to start with what is sort of a visual programming rite of passage, and that's to take our ball that we're now familiar with that goes off the screen and takes off. We're going to make it bounce back and forth, sort of like a mini pong type of a behavior. And in order to do that, well, let's go over to the whiteboard. We have to think about a few things here. Hopefully you see this whiteboard. Gosh, I hope. All right. So let's say we have a canvas that we're gonna make. It's 400 by 400 pixels square, and we are going to take our ball that we know, and we're going to send it from the left to the right. We know how to do that. We programmed it for a couple of weeks now. But what we don't know much about yet is if we want it to go back the other way, what do we need to do once it gets to the edge of our canvas, at the far edge of the screen? We have to build in some logic there. So we could, and this is slides from the last time around, so I actually wrote this in here. You might think one way that we could, try to test that condition is to say, well, when x is equal to the width of the canvas, because we know the width variable in P5 is built in. So once we know the canvas is 400, we can say, well, the width will be 400. So we can say, if x is equal to the width of the canvas, then we should, maybe do something. And let's try out that logic and see how that works for us. Let's go into code here, which should be here. All right. I'll just familiarize you. I'm going to play this sketch here. You've seen that one many times. We have a canvas, just as I promised, 400 by 400 pixels square. I'm filling that ball with a pinkish color, and I'm drawing a dark gray background. We've done that. That's old hat. And this stuff is commented out for the time being, so we'll pass over it. I'm putting an ellipse at height divided by 2, so sort of like midway down the canvas. And I'm sorry. I think I glossed over the fact that way up at the top, I have declared a global variable that will contain the x position for our ball. So I'm assigning it an initial value, initializing it with a value of 0, and then I'm drawing our ellipse at 0 on the x-axis, height divided by 2 on the y-axis, halfway down the canvas, and then our 50 pixel ellipse. Then I'm incrementing x by a value of 3, and I'm doing the whole thing again. So next time around, x is equal to 3, the ball moves off to the right-hand side of the screen. Okay, so we have to think about our condition for what happens when x is equal to the value of the width of the canvas. I'm going to give that a test, and we'll see how well that doesn't do for us. You'll see that, well, actually, what to do. Like, we don't have anything. It's not doing anything. So what if we say, again, using some flawed logic that we're going to clean up here, but what if we say, well, when x is incrementing by 3 each time, once it gets to the width of the canvas, maybe we'll back it up. We'll subtract 3 instead of adding 3. So we can say x equals x minus 3, maybe, right? Try that out. And we're going to hit go, and nothing's going to happen. So what's wrong here? This is your life for the next 12 weeks of class, trying to debug these kinds of crazy logical errors that you can't figure out. And I'm going to kind of tease this one apart for you, but we see here that we are creating canvas of a width of 400. So we know that width is equal to 400. And then we have this x value up here on line 9 that starts at 0 and then increments by 3 each time around. So it goes 0, 3, 6, 9, 12, blah, blah, blah. Gets near 400, and then it's like 399, and then it goes to 402. So this condition here, x equals width, never will evaluate to true because x is really never equal to 400. It's equal to 399, and then it hops over to 402. So how do we fix that? We know from the last video that we have these other logical operators. We can do, well, what if x is greater than or equal to the width? That makes sense, right? So 402 is greater than 400, so that'll trip the condition, and at least we can now execute this line of code on line 27 that's going to back up the ball 3 pixels. So let's give that a shot. Okay, we hit go, and then the ball glues itself to the right-hand side of the screen and shows over. We want it to bounce back the other way. So how do we fix that? Again, we'll look at the logic, and let's go through the code. Okay, we start at 0. X is, incrementing by 3 each time after we draw the ellipse, and then when it gets to 402, we say, okay, when x equals 402, now this line of code is going to execute. So what happens here? So when 402 is greater than or equal to than 400, yes, okay, what do? We subtract 3. So now 402, x is now equal to 399. We draw our ellipse at 399, then we add 3. It's 402 again. Guess what? We go back to line 25, and 402 is greater than width. We subtract 3, and it's now 399. So essentially what's happening over here on the right-hand side of the canvas is that the ball is just kind of glued to 399, and then it doesn't go anywhere. Because this x value in code is only equal to either 402 or 399. So how do we fix that? And this is another thing that you could probably, I want you to recreate this sketch on your own without looking at my code. That's a challenge for this week. But what I'm going to do is I'm going to create another variable. Instead of just incrementing or decrementing by 3, what if we create this other variable that's going to hold the value of our speed of our ball? And we'll say let speed equal 3. And then in our condition, rather than saying x equals x minus 3, what if we did something like speed equals the inverse of speed? What's that going to do for us? Well, speed is equal to 3, and then we can flip it to be -3. So rather than adding 3 to x, what if we added speed to x? So while speed is positive, it's adding 3. X equals x plus 3, just like it was doing before. But when we get to the width of our canvas and the x value crosses over that threshold and it's greater than the width, now we're going to say, well, look, now speed's equal to -3. So when we get to line 34 here, we'll say x equals x plus -3, or x equals x minus 3. Let's try that out. Let's cross our fingers. All right, we got this, and cool. We got the right-hand side of the canvas behaving the way that we want it to. We just need to now figure out how we're going to deal with the other side of the canvas back when x is less than 0. So you guys are probably figuring it out before I can even type it, but we can use another of our logical operators, the logical AND operator, and we can say something like x is less than 0. Right? So now we can say, well, if x is greater than the width, not and, I'm sorry, this is going to be or. Why is that not and, right? So, well, of course, x can't be greater than the value of width and less than 0 at the same time. That's just, you can't do it. You can't be 402 and -1 at the same time. So that was the wrong logical operator. So I'm thinking through this, and it's going to be, if x is either greater than the width of the canvas or it's less than 0, then we're going to do that speed flip trick. Let's try it. And crossing our fingers. All right. So success. We've made the ball bounce back and forth on the screen. Digest this. This is a very common thing that you will do in programming, especially if you're doing behavior of stuff and you want to keep it on the screen. Instead of x, we would also do the same kind of thing for y. We could have x speed and y speed, and we could change both of those and toggle them positive and negative. So try and recreate this sketch without looking, watch the video, obviously, and digest it, and then go and code it yourself without looking at my code. See if you can do the same thing.